All right, let's get started. So, quick reminder, I'll keep it way briefer than I did on Monday, but team formation deadline is coming up. Make sure you get it in. If you're forming a team, make sure you submit that form, or at least somebody on your team submits that form. If you want to be put on a random team, just do nothing, and you'll get an email from me Friday night or Saturday morning with your team listed. Can sign up for a presentation time. It works now. I had the link set up. Little wrong. It's fixed now. You can click here and sign up for a time. Especially if you're forming a team across sections, make sure you can make a time, and I would recommend locking up that time sooner rather than later. Anybody have any questions on that? Okay, we gotta make up some slides from last time. Let's do this. This is pretty much where we were last time. Let's finish this up. Is the biggest thing that I want to make sure I say, I had to rush it real quick at the end, but let's highlight it a little more, is whatever you name your service in your Docker Compose file, that's going to be the host name for that container when you're trying to talk across containers. So when we're connecting to our MongoDB database, our database server, we're not connecting with localhost like we did earlier in the slides and what most of the documentation out there is going to see, all the examples and everything. It'll say localhost. We want to change that to the host name of our database service, which is whatever we call it in the Docker Compose file. We want to make sure that that's the name that we use when we connect. That is the host name that Docker Compose will use when it creates a network for our network of containers, our two containers here. That's the host name. This is whatever you name it. So if you name it something dumb in your services, just make sure you're consistent and use that same name in your code. There's nothing special to the string Mongo here. That's just what I decided to call my service because that makes the most sense. It has nothing to do with it being the name of the image. It's just this name that makes sense. But whatever you name it here, you have to name it here. And the slide is slightly broken. You do have to rename it right here as well, because this is also the host for your database. So you'd have to change it here as well. I meant to update that. I forgot. But make sure you're consistent with these. That has to be the name of your database when you connect to it, your database server. And Docker Compose up is going to spin up both your containers, and you're up and running with the database. Then HTML templates. We have a situation here where we don't want to serve the same HTML every single time to every single user. Right from homework, what am I saying? Starting with, I should say, Objective 2, LO2 on homework 1, you have to serve up HTML that says the number of visits for that particular user using their visit counting cookie. So how do we do that? I don't have a ton to say about this. I just want to make sure I pointed out that HTML templates are a thing, that's what we're doing. Is instead of writing the entire HTML file, reading that file and then serve it up, that's what we do to start, and that's fine. But once we want to inject specific information for a specific user onto that page, what we're instead going to do is write partial HTML files called templates, HTML templates, read the template, and then render the template on our server, and then send that. We'll talk about, I don't know when, at some point, maybe. I don't know where this fits in lecture, but we can also render it client-side. We're going to render them server-side for now. Some of it's being rendered client-side with our chat history for what it's worth already, but with HTML templates, we're going to render them server-side. So we generate partial HTML templates with placeholder values where the actual values are going to go. In the HTML I give you, there's this placeholder for the visits. And I like to use the curly brace syntax, the double curly brace syntax for placeholders. Here I have placeholders for title, description, and the image file name. I stole this syntax from Handlebars, which is a template engine that when you don't have to do this on your own and you use an engine, it's one of the engines that you can use out there for like your project in the real world. And they use this kind of syntax where they put placeholders, like this is where the title is going to go, this is where the description is going to go, this is where the file name is going to go for that image. And then you read this HTML from disk, treat it as a string. HTML will be valid string text, unlike our images, so convert it to a string. Or actually, you could do this in the world of bytes, too, if you wanted to. Whatever you do a replace on those placeholders and replace them with the actual values. Python has a nice just dot replace method, super easy to work with. You would replace this placeholder. I like the double brace syntax because it's unlikely that this placeholder will just naturally occur in your HTML, and just don't put it in your HTML at all. And if you do, escape the curly braces. And replace this with the actual title for that page load. This lets us have more dynamic content. We can make our HTML custom to the specific user. Our very first instance of that is the visit counter. Can we just get one integer placed in that HTML? And then this, of course, will get more complex as we go forward. We are kind of having the same problem with chat. Like, we have to render all of this chat, which will be different all the time. But we're doing that with AJAX requests and rendering it client-side. So it's a little bit different approach that we have for that. But we will be doing more and more HTML templating, as you have to have more and more custom information that you're sending to a specific user. So this is my recommended way. Just put your placeholders. And there are more advanced things we can do with this. When you start using template engines out there in the real world, they'll support features like loops, having this content looping over a data structure and adding this content to your page for each element of that data structure, and also conditionals with if and else. Oops, I'm still on loops. With if and else. So if this expression, just like an if else, but in an HTML template. I always try to explain these to the class every semester, and what I end up getting is students will put one placeholder that says, here's where all the stuff goes, and then use their code to do the loops and all that stuff, which, you know what, fine. I'm not going to fight that battle. So if you want one placeholder that says, here's where the stuff goes, generate all your HTML in Python, and then do a replace that one placeholder with all of your generated HTML with your Python code, go for it. It's a lot easier than doing all the string parsing to find all these tags and doing the more complex stuff. So I'm fine with that. But whatever approach you use, you do need custom HTML, and this is the way to do it. HTML file is just a string. Read that string, and then do all your string manipulation magic that you've learned over the past however many years, several years. Okay, any questions about this, about wrapping up this content? That's my last slide, right? Get into today's content. HTML injection attacks. This is a very, very scary attack because it's very easy to pull off, but luckily it's also very easy to prevent against. But it's something we need to be extremely aware about because if you release something that's vulnerable to this attack specifically, your app will go down in potentially minutes. As soon as somebody gets their hands on your app, it's just gonna be a mess. I know because I've done it before. Releasing a site that's vulnerable to this to a group of students, they'll absolutely destroy the thing. All right, so let's talk about what this is, what an HTML injection attack is. So we used to, I say used to, but for a few weeks, just host static web pages. That's all we did was just sent content to them. We started out by just saying hello. Then we started sending HTML and CSS and JavaScript and images and all that stuff. To host a static page, which I call poster sites, it's just information that's out there displayed to anybody on the internet. When you have these kind of pages, there's really not much security risk at all that you can have. There's potentially some crazy things that people can do. But if your whole goal is just to disseminate information to people, and all that information is public, you have no private information that you have to protect, there's just not much that you have to protect against. And when you're not doing the second thing, is handling user-submitted anything. If you're just having a static web page, you don't handle, the user can't post anything to your server. Your server just doesn't handle getting information from the user. Like, what's the user even going to do to attack you? They can do things. There are things, but not much. But once they can submit content, and we have a web app, which we do at LO3 of homework 1, once they can submit chat messages, in our case, our first case, they can submit chat messages. Now we have some danger. What we're doing is taking chat messages from users and displaying those messages to all other users. We have to be careful about how we handle this, or else somebody who can get something malicious in chat can affect all of your users. And you should never trust your users. So there's a temptation to say, well, my users aren't going to do anything bad. Like, they're my users. I love my users. I'm just going to trust them to not do anything bad. They're all going to do the right thing, right? No. Never, ever, ever, ever trust your users. Do not trust your users. You must protect against everything. Anything they send you, you need to validate server-side. You need to double-check everything. You need to treat everything as if it's the most, anything a user sends you, like it's the most toxic thing ever, that you have to be very careful about how you address that information. Never just say, I trust them. They'll do the right thing. No. And you might be tempted to actually do that. Like, to be fair, like 99.99% of all of your users are probably going to be perfectly fine. Most of them aren't going to want to do anything malicious. I think most people are just generally good enough that they're not going to want to break things or steal things on your website. And of the people who would break things, who would want to break things, most of them are probably too incompetent to actually pull off a successful attack. So you only have a very, very small group of people who might do something malicious and be capable of pulling it off, but that group is not empty. It's not 0 people. And, okay, well, but my users? There's no one like that among my user base, right? Okay, maybe your users are all legit, and they're like, okay, I'm happy using this app. Why would I want to do anything bad to this app? But you know what? Who else has access to your app besides your intended users? Friggin' everyone. Everyone with an internet connection has access to your app. That's why you built a web app, right? Is so it can be easily accessible from anywhere on the planet. As long as you have an internet connection and an internet-connected device, you can access that web page, which is friggin' everyone. So, okay, maybe you do actually trust your users, but do you trust literally everyone? Even someone without an internet connection could borrow one, could travel to the local town that has an internet connection. Do you trust literally everyone on the planet? Billions of people? Because even if you want to be really naive and say, well, everyone I've ever met in my entire life has been trustworthy. I trust everyone I've ever interacted with in my entire life. But yeah, there's people you've never met, billions of them. Do you trust every single one of them also? And goodness gracious, I hope the answer's no. I hope you say no to that. I don't trust literally every human being ever. You know what? That's not even strong enough. It could be an AI. It could be scripts and stuff launching attacks. It's often the case, actually. It's some attacker writes a script and just lets that script wreak havoc on the internet. That it's not even a person actively attacking you. It's just some software running somewhere that's attacking you. It is often, in my case, when I've been attacked, that's usually what it is. At least what it looks like to me is just some script somebody wrote that's just destroying the internet, destroying whatever they want. So do you trust literally everyone? If you do, yeah, don't worry about security. Just go out there and, I don't know, things are going to not end up well for you. But you don't trust literally everyone. The internet's a global thing. Don't trust everyone. So when I say don't trust your users, this is what I mean. I will say this. I'll parrot this throughout the semester. Never, ever, 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 ever trust your users, because your users aren't just your users. It's everyone. Don't trust every single person. Billions of people. Don't trust them all. There's at least one person out there who's going to hack you. How have you been attacked? I shouldn't even said that, because I'll end up on tangents here. I'll try to make it brief. When I mentioned MongoDB, and I got to get this in a lecture somewhere, but I got to figure out where it fits. I could do an example of this. MongoDB, I mentioned that it blocks outside connections, and that's the default behavior. You don't have to set up your passwords or anything. But if you go into your Docker Compose, and I won't show this, I'll say it right now, but don't do this. If you go into your Docker Compose and map port 27017 to 27017 for your database container, so you can access your MongoDB database from outside the container. That way you can use something like MongoDB, Mongo Compass and view your stuff, which if you're doing that in dev, yeah, but don't ever release code like that or else you'll end up like I did. When you have that open, what I didn't know, what I wasn't aware of at the time, is that will bypass MongoDB's security, the blocking outside connections. Because when you map the port, Docker Compose gets a request on localhost 27017 or whatever port your app is running on, 27017, or whatever host your app is running on. Gets a request for 27017, forwards that request to 27017 inside the container, and at that point, the request is coming from Docker Compose, which makes it look like it's coming from inside the container, and MongoDB says, oh, this is a local connection that I'm getting right here because it's coming from Docker. I'm going to treat this as root and give it access to everything. And what happens is there's a script. I saw this happen to several students in the course too, deploying their teams, deploying their projects with that mapping, is the script will go in. It has to be a script because it works way too fast. Is it goes into your database, deletes all of your collections, deletes all of your collections, creates a collection of its own that says, I think it's called README, or no, it's like called We Hacked the, I don't remember what it's called, but it has one document called README, and then it says, we have your data hostage, send us Bitcoin or whatever, I forget the details, but send us money and we'll give you your data back because we're holding it hostage until you pay us. And it was just a test app, so I just laughed and used it as a lecture example now. I didn't lose anything of importance. But it's crazy how it is out there. Like you might think, nobody's going to waste the time to hack my app. No, it's just a script they're running that looks for that, MongoDB with open ports and open to all connections and just exploiting that. Just scanning every IP address, 27017, and looking for an open connection MongoDB and then doing their thing. So be careful out there. Attacks do happen. Yeah, nothing of important was lost. Nothing important was lost in that one. So luckily, it was just a good learning lesson. Yeah, push email to GitHub once. It was found used to send spam. Yep, that'll happen. Email password. Auth tokens. Make sure you're not, if you have auth tokens, or not auth tokens, access tokens for an API, don't push those to your GitHub repo. There are bots that are scanning for that stuff. Email passwords, as was just mentioned. Got to be careful out there. Injection, oh yeah, somebody will definitely do what we're talking about today, HTML injection attacks, SQL injection attacks. You'll see attempts like that all the time, especially if your app is known to a group of computer science students like this. You're all good pen testers. You're all going to try to attack it and inject things. We have a team. I was scanning in the team names already. We already have a drop CSE 312 tables. I forget the exact one, but drop tables, CSE 312, something like that. Those kind of attacks will happen. They'll be everywhere. You just got to be safe. As long as we're safe, they won't get through. You release an app that's vulnerable to HTML injections, it'll go down immediately. All right, tangent over. Let's get on with it. What is HTML injection? So what somebody's going to do, you have your beautiful chat app, and you think people are going to say hi and talk about gaming and stuff and the weather, whatever, and you release your app, and somebody says this in chat. You say, oh, crap. So what they do instead is write some HTML in chat, and if you're vulnerable to an HTML injection attack, this message is going to be sent to all of your other users. This malicious user sends this in chat. Your app does its thing, listens for that at that endpoint for the post request, takes that chat message, stores it in the database, and says, thanks for your chat message. And then another user comes along, visits your page, sends a GET request for all the chat history. You go to your database, you grab all the chat history, including this malicious string, send it to that user renders that on their front end as HTML. That HTML contains a script element, and that script element runs whatever JavaScript the attacker wants to execute and does whatever they want to do that they can accomplish with JavaScript on that front end. And all of a sudden, every single user of your site is hacked. Don't like this. This is bad. Hopefully I don't have to explain too much why this is bad. This is very bad. Oh, I already read that one. Very, 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 very bad. But preventing against this is very simple. So the attack is very simple. You start typing some JavaScript, basically. So anybody, like any one of you in this room right now, can launch an HTML injection attack if a site's vulnerable to it. What you do with that power and how much you can compromise, is up to how much cool code you can write to take advantage of it. But you can definitely destroy the app. My favorite attack is less than, exclamation point, dash, dash. And then that's it. I'll just start a block comment in HTML, and everything after my chat message is gone. The rest of the page has just disappeared. It's all commented out. That's the easiest thing to do, 4 characters, and you can destroy half a page. And usually the page just won't work after that. But preventing is very simple too. What we're going to do is escape these 3 characters, ampersand, less than, and greater than. If I take away these 3 characters, try to write any valid HTML, much less a script tag. Once you can't write tags, you don't have greater than or less than, you can't write a tag, you can't create an element, and you're just stuck at go. You can't do anything anymore, and successfully prevents the attack. That's all we have to do. We're going to take these 3 characters and replace them with their HTML escaped values. We talked about this earlier in the course, Monday of week 2, talking about front end, where we have this ampersand, this syntax where we can specify the bytes of any Unicode character and have that Unicode character rendered to the screen. And then that some characters have named constants, like these ones, amp, LT, and GT, so we don't have to remember their UTF-8 code points, which who's going to remember all those? I mean, maybe you do. But we just remember these AMP, LT, and GT for these symbols. Replace these symbols with their escaped counterparts, and we're done. That's it. So we're done. We're secure, we're safe, no HTML injection attacks. The browser, when it sees these sequence of characters, it'll render them as the characters that they represent. So the user will see, won't know that anything's escaped. It'll just render as text, but it won't be interpreted as HTML. It'll just be interpreted as raw text. And that's what we want. The order is important here. A subtle point, but important, because I've seen students do this before, so I added the slide, and then I haven't seen it since. So everybody's going to pay attention to this, and then I won't have to see it again. It's not the biggest deal, but the order is important. Make sure you're doing your ampersands first. When you replace your less than and greater than, the escaped characters contain ampersands. So if the ampersand itself, I'm on the wrong slide. Order is important. So if you take your LT, your ampersand LT semicolon, and then escape ampersands after that, you're going to escape the ampersand, which was part of the escaped LT and GT, and you're not going to get exactly what you want. Now the user is actually going to see the escaped sequences. The user's going to see ampersand, because this will render as ampersand, and then LT semicolon script, ampersand GT semicolon. That's what the user's going to see, not the original text that was submitted. So just make sure you do this in the right order. Ampersand first, and then the other two, just so you don't escape the escaped characters. It's not the worst thing. You're still protected against attacks, but it's just gross. You don't want your user seeing ampersand LT semicolon. That doesn't mean anything to a typical user. Okay, any questions about this? Is it illegal to launch attacks? Only if you get caught. Is it illegal to be vulnerable to attacks? I mean, it's such a deep question. Could we talk about this the rest of the lecture? Is it illegal to launch the attacks? How do I give a short answer to this one? I don't know. I can't just give you an answer. It's a very, very deep question. But when you talk about legality, you have to talk about jurisdictions. So under which jurisdiction would it be illegal? If it's illegal in the United States, they're going to operate out of, the internet's global. They're going to operate out of some country where it's not illegal. And what are you going to do? It's not illegal where they are. Who the hell is going to come after them? They're going to cross international lines to, it's just a hard thing to answer. Where they're operating out of, it's probably not illegal. I'll say that much. I would venture that guess. But then also, how are you going to catch them? Now, I could get their IP address, but they're probably using a VPN. I could contact them and send them money and try to extract some information that way. I don't know. Just be secure. You don't have to worry about it. But I think the more interesting question really is it illegal to have an insecure app? If you're handling private, sensitive user data improperly and horribly when you should know better, I think that's the bigger concern, to be honest. As a developer, I think that's the bigger concern. It's not illegal, by the way. You can be as irresponsible as you want. But that would be the more interesting one. I don't want to go on too much of a tangent. I do, but I gotta resist a little. Because you could extend that too far and say, well, my user should have had a strong password too, because if a user gets hacked, and I think that's a bit too far. You can't say that. But as a developer of an app with a bunch of users, there's responsibility that some developers don't take seriously, and it makes headlines. Breaches happen, and then nothing happens after that. It's like, oh well, you messed up. Let's move on. And I don't know. It's kind of crazy the way it works. We can have the Equifax leak, which was a while ago now, but Social Security numbers, credit reports, and financial data of millions of users, and it's just like nothing happened. Nothing happened to Equifax. They're still running. They're still doing business. They're still a very important company in the United States. Cross-site scripting is the same thing. I need to add that to my slides at some point. XSS, if you ever see that acronym, cross-site scripting, that's the same thing that we're talking about here, where you're injecting scripts into other users' browsers. I just call it HTML injection text, which implies that you can inject JavaScript as well. I'll go a little further on this tangent. It is related to today. We're talking about security today. The Equifax breach, they were using third-party software that had a default password, and they never changed that default password. So somebody who knew went in and said, "Hey guys, I contacted I accessed this port and noticed you're using the default password. Maybe y'all should change that." And they said, "Nah, we're not gonna." And then they got hacked. Like, what do you want? They couldn't have made it more. They couldn't have been more negligent in that case. It's just frustrating that stuff actually happens at such a huge scale. Okay. Anyway, I don't want to just rant, but breaches do happen out there, and nothing happens to either the attackers or the victims. Now I back myself in a corner. The negligent, not the victims. The victims are different than the devs. I want to make sure I make that distinction. But the negligent who created the possibility of the victims. If you use the put request to update a message in your database and put script in your message, would it have the same effect as an HTML injection? If you use put request, I wasn't expecting that twist at the end. If you put request to update a message in your database and put script in your message, would it have the same effect as an HTML injection? Yes. Yeah, because when you update your message, then if you update the message, then that updated message is still being rendered to your other users. That's still an HTML injection attack. If you're asking specifically for the homework, I did not explicitly put security on AO2 for the put requests. So you will get away with it on the homework if you're vulnerable to that on your put requests, if you're asking specifically that. That doesn't mean it's an okay thing to do. It just means I forgot to put it on the homework. If it's not on the homework document, I will hold to that I won't make that a security thing because I didn't label it in big, bold, red letters, which I shouldn't have to anyway, but I will stick to this. This will be my standard for the semester. I didn't label it as a security thing, so I won't hold you accountable for it. But it is still a security concern in the real world. You'll just get away with that on the homework if you don't do that. Okay, let's get on with it. So let's do some demos. Where are we? Here. Running my app. Everything's fine. Okay, so I have chat. Hey, it works. This is chat as of mostly homework 1. I think I have a few things different, like the path is chat history, not /chat messages. I think I changed the path, but it functions the same way that you would expect. And I am not protecting against HTML injection attacks. So I can type some HTML, and it'll be rendered as HTML. You can see the lag there. I think I had this set to 2-second polling, so I'll wait up to 2 seconds to be able to see my message if I don't hit refresh. And if I want to be obnoxious in chat, any HTML is going to be rendered to all users because I'm not protecting against HTML injection attacks. I'm not escaping anything. So you can do obnoxious things. That's one thing. If that's all people did, it'd be annoying, but who cares that much? It's not the biggest deal. So let's start actually attacking things. What I want is to do what we did in the slides. I'm going to add a script, you've been hacked. I'm just going to log it to the console, just as a proof of concept that we can hack someone. So I'm going to send this, and if I go to the console, we're going to see nothing. It actually didn't work. I got my nice message. That's just what my API responds with when I send a chat message. But I didn't get the hacked thing. And if I have another user who goes to the page, this is the person we want to hack, they didn't get hacked. Didn't work. The reason is the way this chat is working is with AJAX and polling. That means we're polling to get the chat history and then rendering all that to the page, but we're adding a script tag after the page loads that won't be executed because the page already loads. The script tags will only be executed on page load, not if it's added after the page loads. So we actually didn't attack anybody. So we're safe, right? We're protected. No. Nope. So let's take a look at our next attack. We're going to do something just a little bit different. And this is how we can get a lot of attacks in, is instead of relying on the page, the browser, just executing our JavaScript, we're going to have to take an extra step. Here, what I'm doing is adding an image. I'm going to add the eagle image, but I'm going to put the height and width both to 1. So I'm going to have a 1-pixel image, something most users are never going to notice is even there. And then on load, when I'm going to react to the on load event, so after this picture is done rendering, then I'm going to run some JavaScript, and then I'll add a little message just so this looks like an actual message instead of the other one, which was just a blank message. Like, this is super suspicious here. This one looks like I just said, hi, you've been hacked. You've been hacked. Anybody who visits this page now is running whatever JavaScript I want to be running on their page. Which this one, just a proof of concept. But let's take this a step further. I want to run this one. This JavaScript is a little bit different. We're going to send an AJAX request, a post request, to this endpoint that I set up, which doesn't actually do anything. It just responds with, you might have been hacked. It doesn't actually, it doesn't store anything in a database or anything, which doesn't matter because this is only accessible on my laptop anyway. I can only attack myself. And then send that with document.cookie, which is going to send all of my cookies to this attack site. Asterisk. I'll explain in a bit. So I'll paste this to chat. Look at my network tab. Oh, and by the way, I got to mention this. I haven't been in the browser console very much in lecture. I think this is the first time, actually. The I don't have too much time in lecture to do a lot of demos, so a lot of the demos I used to do in lecture are moving to recitation. So recitation is where you can see a lot of the demos and the hands-on and the practical stuff. So if you want more of this stuff, recitation's got it for you. So now I'll look at the post request. Bless you. I sent off a post request to the fail me path with 761 bytes of content of plain text that contains all my cookies. Just sent to whatever attack site I want. Now, to an unsuspecting user, it just looks like I said hi chat. Doesn't look like anything. This is all just happening in the background, but I just stole all these cookies. Now, there's a few things here. I said asterisk. I've got to explain that. This is going to send all of the cookies. Oh, and this is the network tab. I didn't explain anything. This is the network tab. These are all of the HTTP requests for this page load and everything that's made after. Here's my chat history polling at, I think, 2 seconds. And whenever I send a message, render messages, it's all right here. So if you want to look at your headers, there is one that I'm glad I remembered. Your headers, I have to go to one where I actually use it. You can go to your headers, all your request headers that the browser sent, and the response headers. One very important thing to check here is your no-sniff. Make sure the no-sniff is actually interpreted by the browser as a separate header like this. You can go to your browser console, look at the requests, search each one of your requests, and make sure you have your no-sniff on each response that's sent. If this is up in the previous header, that means it's not using the proper syntax, it's not set up properly. You have to fix that. You have to do something. And please double check to make sure all the spelling's exactly right. The TAs and I started a discussion of if it's no sniff with one F, is that a 0? Because technically, yes, it is. It's a 0 by the letter of the law. It's a 0. Because if it's spelled incorrectly, the browser will not disable sniffing. It won't do what it's supposed to do. So we didn't arrive at an answer. I don't know. It feels too strict, but at the same time, your header didn't do anything. I don't know. Just double check it, and then I don't have to decide. Do me a favor there. Okay. So we send all our cookies. The asterisk is, if I go to application and go to my cookies, I can view all of my cookies for this app, and the cookies that won't be set are the ones with the HTTP only directive that's set. So we really like this. We have multiple layers of security in ideally everything. Anywhere where we can get extra security, we're going to. So we're going to protect against HTML injection attacks. One of the things people will do if we're vulnerable to HTML injection is try to steal cookies. And the big attack, the big target is authentication tokens. If you can steal an authentication token, you can log into that app as that person, which we'll see next week. I'll make sure I get to do that demo in lecture because that's one of my favorite ones. I'm going to steal that one. But if we have the HTTP only directive, even vulnerable to HTML injection attacks, that's cross-site scripting, the attacker still can't steal those cookies if it's HTTP only because document.cookie shows all of your cookies that don't have the HTTP only directive set. That was the asterisk. Okay, let's go break some stuff. Yep. Yes and no. This specific attack wouldn't work, but it doesn't mean your cookie's completely immortal to being stolen. One, if somebody has physical access to my laptop, they can just copy this cookie. But also, users can change this. So I say never trust your users in the context of somebody out there is going to want to attack you. But even negligent users can just undo that HTTP only. So even though you set the directive, doesn't mean it's going to stay set. And most users would never do what I just did here. But what they might do is I gave this example in the last lecture, but it's wrong. I'm going to give it again anyway, is download an extension on their browser that disables HTTP only. The browser extensions can't actually do that because they work through JavaScript, so they wouldn't be able to do that. But if they do modify their browser in some way or go into their browser settings, like deep into their settings, or run a program that changes their settings for them, they might accidentally disable HTTP only in some way. So we can't 100% rely on that. That's why we like layers upon layers upon layers of protections to make sure that our users are as protected as we can get them. But it's not always going to be 100%. Any user who wants to be insecure, like if they get an email that says, oh, go to application, go to cookies, and copy this value and send it to me. I'm from Microsoft Help Desk. I'm here to help, or whatever. Like that user's going to be compromised. So hesitant on the can never be stolen, but that's our protection. This attack won't work. I gave a too long answer to that question, but yep. Does the cookie have to be hashed? Yeah. Not necessarily. Usually they're not. I want to try to give a short answer because I will have a lot to say about this in a future lecture. Hashing wouldn't add extra security. We can encrypt them, which will add some security, or sign them with encryption keys. But even then, if a user steals the token, they'll have whatever the server's expecting. So it'll still be legit. It'll still be treated as a valid token. Because if it's hashed, the user's sending the hash, the attacker's sending the hash, browser can't distinguish between them. That's my short answer for it. I like that one. Okay, let's break some stuff. I got to get to the end of this. So when we're on a page, when somebody visits a page, what we do on our server is send them HTML, CSS, JavaScript, multimedia. We send them all the stuff, and they download it onto their laptop. So when I visit a page, what I have on my laptop are all of the bytes for that page. And if all those bytes are on my laptop, I can do whatever I want with them. Like I have physical access to everything about that front end, and I can manipulate everything about it, which means your users can too. So never trust your users that they're going to send you the right information, but they can also modify your front end and send you information you might not be expecting at all. So the simplest thing, I'll start with a simple thing. If we click this button in the browser console, we can edit the HTML to whatever we want. And the simplest thing is just delete things. If I want to destroy part of this page, I'm only destroying my local copy on my laptop, but I can modify anything that I want. So if I don't like the grading structure of this course, I can just go in here and say 0 through 12, I pass. And oops. -1 is an F. Now I can't fail the course. Like you can change everything. Obviously, this doesn't change the course policy or anything, but the users can do whatever they want to your front end. So here I have an example just from W3 Schools of some checkboxes. And the way this one works, just to show you the intended functionality, if I go to the Network tab and I click a few of these things, when I submit this, it's telling me what was submitted, but we can also verify in the console. What this is going to do is submit this form. It's not using any method or encoding type. We haven't even talked about encoding types yet. So what this is going to do is send a GET request, that's the default, using a URL query string with the keys and values. And we have name, vehicle1, value bike, name, vehicle1, value bike, and it's going to tell me all the checkboxes that I had set. Now, obviously, I can just change the code here because it's W3 Schools. But to show you that I could do this on any page, I'm going to go over here and modify the HTML. I can do the same thing that we just did, deleting things and changing the grading on CSE312.com. I can do the same thing here. I'm going to reverse engineer these text boxes and send whatever I want to the server. So name vehicle1, that's fine. The name is going to be the name sent to the server as the key for this, and then the value of any input, the value is going to be what's actually sent over to the server. Now notice that the value is different than the actual text associated with it. It's different than the label, I have a bike. When you click this, what it's actually sending is the value, which is bike. So if I want to change this to whatever I want, and I select these checkboxes, go to the network tab, what I'm sending... What I'm sending is, if we get there, is whatever I wanted to send. Vehicle 1 is now motorcycle. Vehicle 2, I eat pie. It's going to be whatever I choose for the value of those elements, of those inputs. It's the value that matters, not the name. Well, the name should be the same because the backend's expecting something of that name. And it's definitely not the label. The label has nothing to do with it. That's just for us humans to make more sense of this input. So, and I want to stop soon, but I want to make sure I say the things I say. You write your code and you say disabled. Now I can't click this checkbox because it's disabled. But we know that it's just HTML. I'm going to go to this thing in my console, delete disabled, and now I can still check this. So never trust your users that they're going to use your front end either. Don't think, oh, I disabled that checkbox so nobody can check it. You have to verify on the back end if they did what they were supposed to do, because they can enable things, they can change the values. In 116, I have the music rating app with radio buttons for 1, 2, 3, 4, 5, but somebody every semester is going to send me 100 because they're going to know how to do this, go into the HTML, edit it, and send me whatever value they want for a song. So on the back end, I have to say, is the value that I got for the rating either 1, 2, 3, 4, or 5 exactly? I have to have that verification on the back end. So never trust your users that they're going to use your front end the way it's intended. They could modify it, or they could just open up a TCP socket, connect to it, and type whatever requests they want manually and send anything they want to your back end. They do not have to use your front end. There's no such thing as front end security. Everything's insecure on the front end. All right, so the music started a little early. And I talked for 2 extra minutes anyway, because the lecture question is a little tougher today. So I wanted to give you a little more time to do this one. If you only have a phone today and you did not bring a laptop, you can come talk to me and we'll figure something out. But you kind of need a laptop for this.